Hello, everybody. Welcome to another day of learning. Yesterday, we had tremendous success, very, very good success. And today, we'll continue our learning journey by going deeper into Kubernetes and getting to know what Kubernetes is all about. Today, we want to go to understand deployment at a deeper level. So let's get started. If you've not watched this, if this is your first time watching this, uh, this is day 9. Okay, to catch up, you may need to watch the previous 8 days. Okay, so that you have a deep understanding of what is going on. So this is what we're going to study using kubectl to create a deployment. So let me just make sure that on this other side I have everything set up. All right, so let's carry on. So it says objectives. Learn about application deployments. Deploy your first app on Kubernetes with kubectl. Okay. Now it says Kubernetes deployment. It says a deployment is responsible for creating and updating resources for your application. As simple as that. Creating and updating resources for your application. So I'll go on to read the note. The note says this tutorial uses a let me first highlight all of this. It says this tutorial uses a container that requires AMD 64 architecture. If you are using Minikube on a computer with a different CPU architecture, you could try using Minikube with a driver that can emulate AMD 62. AMD 64, okay? Then they're saying, for example, the Docker desktop driver can do this, okay? So I have Docker desktop on my machine. Here it is, okay? I would expect that this is okay, okay? So let's go ahead. So this is once you have a running Kubernetes cluster, you can deploy your containerized applications on top of it. Okay, and yesterday we looked at how to create a cluster. So they're saying to do so, you create a Kubernetes deployment. The deployment instructs Kubernetes how to create and update instances of your application. The deployment instructs Kubernetes how to create and update instances of your application. Okay, so the first goal is to create a cluster, which is a group of those machines having nodes. Then we create a deployment. Okay, so we create machines, one machine or more, where the application will reside. Then we create the deployment, and this deployment simply instructs Kubernetes to create and update instances of our application. So they're saying once you have created a deployment, the Kubernetes control plane schedules the application instances included in the deployment to run on individual nodes in the cluster. Sorry, we got kind of a cold. Let's continue. Saying once you've created a deployment, the Kubernetes control plane schedules the application instances included in that deployment to run on individual nodes in the cluster. So we know there's a cluster, every cluster has a node, okay? And now once we have created the deployment, Kubernetes, the control plane of Kubernetes schedules the application instances, which are included in that deployment to run on individual nodes. So it goes on to say, once the application instances are created, a Kubernetes deployment controller continuously monitors those instances. Okay. So the scheduler, the control plane ensures that the instances are created after they have been created. Okay, the controller has to monitor and ensure that are these instances running? Okay, are they running? Then it says if the node hosting an instance goes down or is deleted, the deployment controller replaces the instance with an instance on another node in the cluster. If the node hosting an instance goes down or is deleted, the deployment controller replaces the instance with an instance on another node in the cluster. Okay, so this provides a self-healing mechanism to address machine failure or maintenance. Yeah, and this is what we want. Okay, this is the best behavior so that downtime is minimized. Okay, if one node which has an instance goes down, okay, so simply we expect that this deployment controller creates a new node. Okay, and this new node simply has another instance. Okay, so they're saying in a pre-orchestration world, installation scripts would often be used to start applications, but they did not allow recovery from machine failure. Yeah, that's the sad part about it. Okay, recovery from machine failure was not possible. So they go on to say by both creating your application instances and keeping them running across nodes, Kubernetes deployments provide a fundamentally different approach to application management. Okay, by both creating your application instances and keeping them running across nodes, Kubernetes deployments provide a fundamentally different approach to application management, like they have explained. All right, so we go on to say now deploying your first app on Kubernetes. And yeah, I appreciate this background given before getting into it. The thing, applications need to be packaged into one of the supported container formats in order to be deployed on Kubernetes. Okay, so applications need to be packaged into one of the supported formats in order to be deployed on Kubernetes. Okay, so yeah, showing us what a cluster is. That a cluster is made up of a number of nodes. Okay, and then we have the control plane. Okay, and then each node has the kubelet. Okay, responsible for managing the nodes themselves. Okay, then we have the app itself running inside the node, and for this containerized app runs because of the container runtime. Then you have the control plane, okay, which is responsible for managing the whole system. Okay, and we have now the deployment. Okay, which is responsible when this deployment is created. Okay, it creates an instance of our application. Okay, on the nodes. All right, so they're saying you can create and manage deployments by using the Kubernetes command line interface, kubectl. Okay, so we learned about kubectl being the tool that helps us to interact, okay, with our cluster. So they say kubectl uses the Kubernetes API to interact with the cluster. You know that the Kubernetes API server is part of the control plane. And it's saying in this module, you learn the most common kubectl commands needed to create deployments that run your applications on a Kubernetes cluster. They're saying when you create a deployment, you'll need to specify the container image for your application and the number of replicas you want to run. Okay. Okay, that is good. Then it says you can change that information later by updating your deployment. They're saying module 4, 5, and 6 of the bootcamp discuss how you can scale and update your deployments. We shall study that soon. You're saying for your first deployment, you'll use a Hello Node application packaged in a Docker container that uses Nginx to echo back all the requests. They're saying if you didn't already try creating a Hello Node application and deploying it using a container, you can do that first by following the instructions from the Hello Minikube tutorial. This is what we did yesterday. Okay. So it says you will need to have installed kubectl as well. If you need to install it, visit install tools. Okay, but no need because we already did it yesterday. So if you haven't, please ensure you do. Then they're saying now that you know what deployments are, let's deploy our app. So the question I should be asking myself, and you should be asking yourself, is do we understand what a deployment is? Do you understand what a deployment is? Okay. All right. So they say kubectl basics. They say the common format of a kubectl command is kubectl action then resource. Okay. Kubectl action then the resource. Okay. They're saying this performs the specified action. Okay. Like create, describe, delete on the specified resource like node or deployment. Okay, so I can say kubectl create, kubectl describe, kubectl delete. Okay, then the resource can be a node or a deployment. So I can say kubectl create node, kubectl create deployment, kubectl describe node, kubectl describe deployment, kubectl delete deployment, or kubectl delete node. That's how I understood it. Okay. And now they say you can use --help after the sub command to get additional info about possible parameters. For example, kubectl get nodes --help. Okay. So get is also an action. Okay. And nodes is the resource. And this is the sub command. All right. Let's move on. So it's saying check that kubectl is configured to talk to your cluster by running the kubectl version command. Okay. Remember, cluster is created by Minikube. Okay. Then you say that check that kubectl is installed and that you can see both the client and server versions. To view the nodes in the cluster, run kubectl get nodes command. Okay. Let's maybe run this kubectl version. Of course, we did this yesterday. I would expect it to work the same way. So let me expand this. Kubectl version. Did I spell it well? So where it's saying command kubectl not found. Okay. I think I spelled it wrongly. Let us see. Cube. Cube. Yeah. Instead of CTL, I put TCL. Okay. So this would fail. Okay. So it's supposed to be cube, then CTL, not TCL. I was going to go crazy. Like this was working yesterday. Okay. So it says the connection to the server localhost 8080 was refused. Did you specify the right host or port? Okay. So we have the client version and the customized version. So this is okay. So we just need that everything works. Okay. If I want to check, if I say kubectl get nodes, okay, this will not work. If I say kubectl get nodes, okay. So you see that the server, we need the cluster, It's trying to communicate to the cluster, but the cluster is down. Okay. So we need to start the cluster. So say you see the available nodes. Later Kubernetes will choose whether to deploy our application based on available node resources. Okay. So to start our cluster, do you remember the command? Was it mini cube start? Okay. Not muni, but mini cube, if I remember. Okay. So instead our cluster saying minikube that on Darwin ARM64. Are you seeing our architecture? Okay. And this is possible because of my Docker desktop. Okay. Like I said, this is the architecture you should be using. Okay. If you don't have this architecture of ARM64, ensure you can just download Docker desktop, okay, on your machine, and you'll have peace. Okay. So it says starting using the Docker driver based on existing profile, starting minikube, okay, primary control plane in minikube cluster. It pulls an image, restarting the Docker engine container for minikube, preparing Kubernetes, verifying Kubernetes components, okay. And yeah, down here now says done. kubectl is now configured to use minikube cluster and default name by namespace. Okay, so I can clear this and now say, since the cluster is now running, I now say kubectl, okay, kubectl get nodes. I think they only have one node having the control plane. You see now how it works? Okay, so if you tried it and it was not working, this is what you can do to see that it's actually working, and it's very, very okay. Amazing, isn't it? Okay, so yeah, let's continue. Okay, but they said you can do, for example, you can say kubectl, okay, then you pass a sub command -- help, okay, to get information about what it does. Okay, but in brief, okay, in brief, how I can summarize it is that kubectl is the command, get is the action, nodes is the resource. So I can say kubectl, okay, get, okay, action, resource, deployments. So you see, no resources found in the default namespace. So you get the goal. So let us go on. Okay. Now they're saying deploy an app. Okay. So the trick here, guys, is to keep on practicing it. Okay. And I'm happy that they keep on bringing back these concepts again and again. In the long run, that is how mastery is going to be achieved in a very, very easy way. Okay. Absolute mastery of what we are learning. Okay. So let's continue. All right. Let's continue, friends. So it says, let's deploy our first app on Kubernetes with the kubectl create command. Okay. Now we should understand what a deployment is. Okay. This, when we create a deployment, now Kubernetes is able, okay, to run our instances, okay, in the nodes which are on the, in the nodes which are on the clusters, okay, and is able to monitor them. That okay, if he said he needs 4, they actually exist 4 instances, okay, running. So we shall say kubectl create deployment. Again, kubectl, okay, so that'll try to type out the commands. Create, okay, is the action. Deployment is the resource. Okay. So it says we need to provide the deployment name and the app image location. Okay. So the deployment name and the app image location. Very two important things. And I think for the image location, they're saying include the full repository URL for images hosted outside Docker Hub. Okay, if it is outside Docker Hub, ensure we put the full URL to it. Okay, if the image is outside Docker Hub, if it's not outside Docker Hub, it can be good for us. Okay, so like for in this case, they're saying the deployment is called Kubernetes Bootcamp. Okay, so I'll go ahead, space, add it. Okay, so kubectl action create the resources deployment, and the actual name of the deployment is called Kubernetes Bootcamp. Okay, we go ahead. Then there are subcommand, the thing minus minus image. Okay, let's continue. Minus minus image equals to, we now have to put this value, which is this URL. Okay, this is the full URL to the repository of the image. Okay, which is outside. So I'll copy it. Okay, go there and paste it. Okay, and I can hit enter. So you see what it says? It says deployments.apps Kubernetes dash bootcamp created. Okay, isn't that easy? Okay, very easy, in my opinion. Then we continue. It says, great, you just deployed your first application by creating a deployment. This performed a few things for you. Okay, it said it searched for a suitable node where an instance of the application could be run. We have only one available node. Okay, it searched for a suitable node where an instance of the application could be run. Okay, this, I don't know if you guys have seen me deploy before on while building the flight booking engine series. Okay, at some point it was a pain. Okay, to have to do to create the machine by myself on AWS. Okay, of course later Terraform kind of helped. Okay, but you must, if you've done this before, you know how important this is. Okay, and then the next thing is saying scheduled the application to run on that node. Okay, so first thing is find a node. Okay, in our cluster where an instance of application can be run. Then schedule the application to run on that node. Okay, then configured the cluster to reschedule the instance on a new node when needed. Okay, so check that there's a suitable node. If there's a suitable node, okay, schedule the application to run on that node. Then in case we need a new node, when can we need a new node? For example, maybe when the previous node has failed, okay, or it has been deleted, then we configure our cluster to easily reschedule an instance on a new node when needed, okay, in case of failures. Okay, this helps in what they call the self-healing, okay, self-healing mechanism of Kubernetes. So right now, if someone asks you one of the unique advantages of Kubernetes, okay, we should be able to answer, okay, and talk about the self-healing ability that Kubernetes has, okay, very, very important. Now we go say to list your deployments, use kubectl get deployments command, okay. Let's continue, okay. So, and actually we did it earlier, okay, but of course you see it says no resource found in default namespace, which is okay, okay, because there was no deployment, okay. So I can say cube, not k, but kubectl get deployments, okay. I hit enter. There we are. We have a deployment, okay, running. So if I say the same thing, get kubectl get nodes, okay, we still have only the control plane. Okay, so the craze online about Kubernetes being hard to understand, I think sometimes listening to noise on the internet is not really good. Okay, we just a little effort we have put in. See how we've been able to create deployments. I now know what a cluster is. Okay, I can easily explain what a cluster is. I can explain what a node is. I can explain what a control plane is. I can explain the components of a control plane. I know what it does. I can explain the components of a node and what they do. I can explain what a pod is. I can explain what a container runtime is. I can explain what kubectl is, what minikube is. So what it means to create a deployment, okay? Pretty easy. So they're saying, we see that there is one deployment running on a single instance of your app. The instance is running inside a container on your node. Yeah, that is it. So the node is the machine, okay? So inside this machine, we have the instance, okay, running inside the container, okay? So the node and the instance running inside a container, okay? How is it running inside the container? Because of the container runtime. Don't forget this, guys, okay? The container runtime. So let's go ahead. And of course, we see that there's one instance because of this, okay, of this result. Let's go ahead. So they're saying now view the app. Okay, let me highlight this first statement. It says pods that are running inside Kubernetes are running on a private isolated network. Okay, you remember what a pod is? They're saying by default, they are visible from other pods and services within the Kubernetes cluster, but not outside that network. Okay, so this is very good that by default we have, think of it like a VPC, okay, on AWS, a virtual private cloud. Like you have a private isolated network from the whole world. So by default we are secure. By default, no one has access. Okay, access is only there internally. Okay, that is a good thing. I like this. So now we go ahead to read. They're saying when we use kubectl, we are interacting through an API endpoint to communicate with our application. Do you remember what we studied in the first 4 days? What gives us this API endpoint? What component gives us the API endpoint? That is called the Kube API server. It is the one responsible for exposing an HTTP endpoint for us to communicate with our application and for the internal components to also communicate with each other. Okay, the control plane communicates with each of the nodes using the endpoints provided by the Kube API server. So don't forget about the API server, very key component of the control plane. Okay, very, very key component. So let's go ahead. Okay, again, like of course, this is just emphasizing the point that kubectl is to help us interact with our application in the cluster. So let's go ahead. So this does not mean that the network is public, okay? Because kubectl is just configured to help us communicate through the API endpoint, but to the external world outside network, we have actually no access, okay? But through kubectl, we can communicate with our application. So they're saying we will cover other options on how to expose your application outside the Kubernetes cluster later in module 4. Okay, we shall look at it soon. They say also as a basic tutorial, we are not explaining. Let me read this again. Okay, English wants to fail me. Also, as a basic tutorial, we are not explaining what pods are in any detail here. It will be covered in later topics. Okay, very okay. I have no problem with that. Okay, let's understand pods in detail later. Okay, the goal is to chew the piece of the cake. I mean, to chew small pieces of the cake little by little. Okay, later when we grow and we have all the teeth, that's when we can chew the more information. So let's go. They're saying the kube proxy command can create a proxy that will forward communications into the cluster wide private network. Okay, the kube proxy, not croxy. What's wrong with me? I want to bite my tongue saying proxy. So the kubectl proxy command can create a proxy that will forward communications into the cluster-wide private network. The proxy can be terminated by pressing Ctrl+C and won't show any output while it's running. Okay? So what we need is access to our application. Okay? This application that we want access to is in a private network, but we can create a proxy which will redirect all our information, all our communication to that private network. Okay. And of course, we can terminate it by pressing Ctrl C, and won't show any output once it's running. So you're saying you need to open a second terminal window to run the proxy. So you can say kubectl proxy. Let us do it. Okay. So I'll leave this one here. I'll come to shell, new window. I'll also expand it. Okay. So you can see it. Maybe put it down here. Expand it, drag, and pull it there like so. Okay. So let's do kubectl proxy. Hit enter. I think starting to serve on this port. I think this first piece is for localhost, okay? Then the port is 8000. Okay? Very easy. Very easy. By the way, let me tell you something. When I was learning Python, I had more errors than when I'm learning Kubernetes. I don't know that it's because of some experience, and now I have built the discipline of having to follow documentation. Probably that could be the reason. But I'm impressed with how things work straight up without having to break a sweat. Okay, let's continue. So it says now we have a connection between our hosts, okay, which is the terminal, and the Kubernetes cluster. How do we have a connection, friends? Okay, this is a question you should ask yourself. How do we have a connection? Because of the proxy. The proxy is helping us to communicate between ourselves, the hosts, and the Kubernetes cluster, which has a private network. Okay, and it's saying the proxy enables direct access to the API from these terminals. Okay. Now they're saying you can see all the APIs hosted through the proxy endpoint. Okay. You can see all the APIs hosted through the proxy endpoint. For example, we can query the version directly through the API using the curl command. For example, we can query the version directly through the API using the curl command. Okay. So we can test this. Okay. So this can be even, I think okay, let me copy it. I think I can open here and paste it. Okay. And you see, we get the result. Okay. Get the major, the minor, emulation major, like that. All the version, Git version, the Git commit, okay, the compiler, the platform, okay, ARM64 like they told us earlier, okay. Isn't that cool? Where is the other terminal? Okay, it's okay. You can find it. All right. So even actually in the browser, let me try to do this. If I go to this endpoint, okay, and I paste it into the browser, you see, there we go, okay. Let me expand it so that you see, okay. So you get a number of paths, okay. This /API, okay, /API. If you remember, you learned about something like this. So you see, we get the API versions, okay. So you see, if I say /APIs, APIs like that, okay, you get the API group list, okay. So very accessible. If I say /version like this, told us to do, there I will get similar stuff. Okay. Yeah. So that's how I try out things. Now let's go ahead to the next part. It says note, if port 801 is not accessible, ensure that kubectl proxy that you started above is running in the second terminal. So, and that's what we are doing. Okay. We run it. Where is that second terminal? It's right here. Okay. Okay. I don't need, I can simply just do this. Okay. Reduce them just a little bit side by side. Okay. There we are. Okay. So let's move on. We're almost there. It says the API server will automatically create an endpoint for each pod based on the pod name that is also accessible through the proxy. Isn't that interesting? But we should, of course, expect this because in the first 3 days when we were learning, we were told that the API server is responsible for exposing an HTTP endpoint. Okay? Not an HTTP endpoint, but HTTP endpoints, which are responsible for communication, for us to access the pods, for the internal components in the cluster to communicate with each other. So this makes total sense. Okay? So an endpoint created for us automatically for each pod based on the pod name. So let's go ahead. It says first we need to get the pod name and we'll store it in the environment variable pod name. Okay. So here they have a command. Okay. Says export pod name equals to kubectl get pods. Okay. Minus O. They say go template. Then they have a subcommand. Okay. Which picks range.items metadata.name, okay? Then they look, I think, for a new line, then they mark the end, okay? This is how they're getting the pod name. Ojin, good morning to you too. I guess you've just woken up. Tell me I'm right. I'm kidding though. Thank you for joining today's stream. Let's go ahead. Then they say echo the name of the pod like this, okay? So if I what? So if I can just copy this first command, okay? I can now clear my screen, okay, and paste it, okay. So this variable pod name has now been set. Then we can now echo, okay. Say name of the pod is this Kubernetes bootcamp blah blah blah, okay. But if you say kubectl get pods, okay, are you seeing this? It's the same thing, okay. But this was what they were just trying to what to extract it, okay, from. I think that they should explain to us what this template is. I think there's a template, okay, which stores this it in like in the pods in this format, okay, that range.items, okay, then metadata dot name, like in that hierarchy, okay, in that YAML format. And it's picked out for us, okay. All right, now that we have the pod name, okay, right here, now we can go ahead. They're saying you can access the pod through the proxied API by running, okay, by running this command. But if you see up here, I want to show you what they're trying to prove. They're trying to prove a point. Where's that statement? They're saying the API server will automatically create an endpoint for each pod based on the pod name. That is also accessible through the proxy. Okay. This is what they're trying to show us. Okay. So now let's move on. They're saying you can access the pod through the proxy API by running. So curl, okay. I think the domain and port, okay, slash API, okay, slash version 1, slash namespaces, okay, slash default, okay, slash pods, okay, then the pod name, okay, then 8080 slash proxy, okay. That's why we needed the pod name, okay. But I think because we are learning, they're trying to just make us understand the whole point. I have an intuition that it is way easier than this, okay. And I'll make a quick guess. It is because of the services that we're going to learn about soon, okay. But let's copy. So I'll paste, and there we are. Okay, if I just make it a little bit wider, says hello Kubernetes bootcamp. Okay, running on that Kubernetes bootcamp, blah 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 blah. Okay, so it's running. Okay, and this is the API endpoint to access it. Okay, but yeah, I'm looking forward to better ways of doing this using services. Okay, because of some experience, I know what services work and what they do. So yeah, we'll look at it together. So we continue to say, in order for the new deployment to be accessible without using the proxy, a service is required, which will be explained in module 4. Yeah. So I predicted well. Okay. We need to learn about services. Okay. Because I want to create okay, the proxy is nice. Okay. Like for maybe just checking things like for the version. Okay. I can do that. But I wouldn't want to have to access my pods. Okay. Uh, using this kind of stuff. Okay. This would be too long. Okay. Just need a service name. As simple as that. Okay. So yeah, we are done with today. Let's meet again tomorrow. Small things, okay? Learning small by small, step by step, but we are moving, okay? We are moving. Before you know it, we shall be applying this to the flight booking engine and your personal projects, my projects, okay? Yeah, and actually, once I'm done mastering this, I'm going to try out actually also freelancing as a DevOps guy. Just need to apply this to some really good projects, okay, like 2, and then yeah, we'll be good to go. So we've come a long way, okay. We've gone through understanding Kubernetes, okay. Do you now appreciate why it was so good to go through this? Okay, I hope now you know understand how it was so good to go through all this. Okay, then we went yesterday. We were at this. Now we are going through this step by step. Okay, yeah. By the time we reach, I think yeah, this is good according to what we have done so far. I'm really happy with the progress made. So thank you for learning with me. For those who love building the flight booking engine, we can meet in the evening. Otherwise, see you tomorrow morning as we study. Time to go to work, especially for us who are starting our day this side. See you soon.